Hello again, grade 11s. I hope that you are well and that you are coping so far with this section. I'm going to go over the corrections from the past paper questions that I gave for homework, and we're going to start with the KZN June 2024 paper. For the first multiple choice, it said, in the circuit diagram below, the resistance of resistor A is double that of resistor B. Okay, this is a very nice question, by the way. I was looking at it now. So I hope that you really took the time to engage with it. So it says, which will be the correct relationship between the charge through resistor A and the charge through resistor B in the same time? Okay, so it's talking about charge and it's talking about the time. So again, that relates to the current, right? So that's a good place to start with something like this. Okay, you must write, there's no guessing here. So you would say, well, current is equal to Q over delta T. But if they said, so this is obviously now for both resistors, so for resistor A and for resistor B. But they said that what stays the same through each resistor is the time part. So that means that I am concentrating on this. Okay, this is not necessarily true. They're not equal to each other. Well, I guess in a sense the relationship would be equal because the time is equal. So that's what we are looking at. So it would actually be better to put the proportionality sign between them because there's that constant. So now let's continue. It wants to know the correct relationship between the charge and the charges through both of them. So it says that the charge through resistor A is double, or it's half, it's equal, or the charge through A is 4 times larger than the charge through B. So the only way to figure out how the charges would compare between the two, because if I think of RA, right, I can see that the current through A would be the charge through A and the time through A. So because the time is constant in both cases, I can compare them by saying, well, the time here is the same. So then I can compare how the charges are going to compare based off the current. Okay, because this is what I'm trying to compare. So I need to say, okay, well, the only way that these two are different is the way that their currents would differ. So now I see and I think to myself, okay, well, is it possible for their current to be different? So, okay, we don't know the voltage, however, we do know that whatever the total voltage is, right, it's the same here and here because it's a parallel circuit and there's no other resistors. So the voltage is the same. So now let's think about Ohm's law now. Ohm's law says that if the voltage is constant, then I can say, well, the resistance is inversely proportional to the current. Okay, so now what does that mean? When I look at this, I see, okay, well, RA has the bigger resistance compared to RB, right, which is just R. It has exactly twice the amount of resistance. So that means that the current, if they are inversely proportional, the bigger resistance is going to have the smaller current. So that means now that the current that will go through this one will be less than the current that goes through the R. Okay, so exactly half. So if the current was I going through R, then the current going through here would be half of I. Okay, or the I would be less. So now if this is true, you see that they're directly proportional to the charge. So if the current, we said I would be Q, right, for B. So if I had half I would have half Q for A. So that means that the charge that goes through A is going to be half of the charge that goes through B, because the current is half through A than it is through B. So if I look now back at this, it says the charge through A is double the charge through B. No. The charge through A is half the charge through B. Yes. The charges are not equal and the charge is not 4 times. So actually, even if you didn't know the constant, right, charge A can't be bigger. The charge through A is smaller regardless. So it can't be double, and it can't be equal, and it can't be 4 times. So actually, even if you didn't know the constant, just by knowing that the charge is bigger at A, you would know then that B could be the only option there. Okay, so just so you can see, there was a lot involved. We had to use our Ohm's law to get the relationship for the resistance and the current, and then relate the current back to the charge. Okay, so it's important to just write the information as you are going. Okay, this is a very nice question. You can definitely expect something like this to come up in your cycles and in your exams. So make sure that you are going over these types of questions and that you understand what has happened. Don't just give up because it's a bit challenging. Okay, you have to try. Okay, then let's look at number 7. So the first thing is number 7 asks you to define EMF. That's the first one. Now, EMF is not to define the EMF is not actually something that we're going to test right now. Okay, that's part of internal resistance, but it is in your SAGS document. So I will write the answer, but just so that you can take note there that it is not something that is going to be asked right now. Okay, but EMF in the SAGS document is defined as the total energy supplied per coulomb of charge by a cell. So I guess it's important to understand, but like I said, it's not really something that we are looking at testing right now. So yes, moving on. Write down the EMF of the battery. Okay, so let's have a look and see. Let's read the top, because we did jump. It says in the diagram below there are 4 cells, each with a voltage of 1.5 volts. So then they tell you A, B, and C have a resistance of 3 ohms, 6 ohms, and 8 ohms respectively. Now remember what we said when I explained what respectively means. It means that A is the first one, which is 3, B is the second one, which is 6, and C is the third one, which is 8. That's what respectively means. So you must go into the diagram and fill all of this in. So A is 3 ohms, B is 6 ohms, and C is 8 ohms. Then they said that each of the cells has a voltage of 1.5 volts. So now there's 4 cells. They did tell you, but if they didn't, you can count. 1, 2, 3, 4 cells. So 4 cells times 1.5 volts is going to give you the total voltage. Now the total voltage then in this case would be 6 volts. Okay, so that would obviously be then the reading on V1. So when it asks you write down the EMF of the battery of the battery is just simply 6 volts. Okay, the third one, if the reading on V3 is 4.8 volts, so now they've given you a reading for V3, 4.8 volts. Notice that the switch is closed. It says the reading on ammeter is 0.6 amps. So they've also told you 0.6 amps here. Okay, so make sure you've put in all the details that they've given you. So they first say, what is the effective resistance of the circuit? So there's 3 resistors. 2 of them are in parallel and 1 is in series. So you must focus on the parallel part first. So you would say, okay, well, the effective resistance, we'd first calculate the resistance in parallel, which is going to be 1 over 3 plus 1 over 6 to the negative 1. Okay, you would put that on your calculator, 1 over 3 plus 1 over 6 to the negative 1, and you would get 2. And then you can calculate the R total by saying 2 ohms plus the one in series, which is 8 ohms, which would give you a total of 10 ohms. So that would be the effective resistance in the circuit. Okay, 7.3.2, sorry, I wrote down the wrong question. So this is 0.1, and then 7.3.2. I'm actually probably going to need a bit more space at the bottom here, so let me just adjust this quickly, and then we can continue. Okay, so 7.3.2 now says, what is the reading on voltmeter 2? Okay, so voltmeter 2 is going to give you the same reading throughout. So it's the same reading here, same reading for this one. So I know the total voltage is 6. And I know the voltage through V3 is 4.8. So then the V2 must be the remaining volts. So I can say, well, I know that the V total is actually equal to V2 plus V3. And the V total is 6 volts. I'm trying to find V2 plus 4.8. So V2 is just going to be 1.2 volts. Okay, easy enough. Then 7.3.3 says, what is the amount of charge that is passing through resistor C in 20 seconds? So the amount of charge Q time has to do with current. So we're going to say, well, current is equal to Q over delta T. They want to know charge, so Q is equal to I times delta T. Now the current through resistor C is going to be the same as the total current, which is 0.6. So I would say 0.6 times the 10 seconds, which is just going to give me an answer of, was it 10 seconds? 20 seconds, sorry. 20 seconds, which is going to give an answer of 12 coulombs. Okay, then the last question. Okay, remember I said these questions always come up. If the bulb B fuses, how will this affect the total current of the circuit? Write down increases, decreases, or remains the same, and give a reason for your answer. So, if bulb B fuses, first of all, the word fuses means that now it is broken, which means that a broken fuse or broken light bulb or resistor acts like an open switch. So when B is now considered fused, it means that this part of the circuit is no longer working. So this is like an open switch, which means that this portion is done. No current can flow through here. Which means that now, if you notice, if I look at how the current is flowing, there is only one pathway for the current to flow through this entire circuit, which makes now the current go from parallel into series, Okay, so what happens? I can see that the resistance is going to increase. Okay, if you want to double check, you can see, well, the total current here we said was 10. Now the total current is 3 plus 8, which is going to be 11. So what has happened is that the current, not the current, the effective resistance has increased. So because they want you to say how is it going to affect the current, you can say, well, if effective resistance has increased, resistance is, current, is the other way around because the resistance won't change. The current is affected by the resistance. So current is inversely proportional to resistance. So therefore the answer is decreases. Okay, and this would be your two reasons. If it's asked you for a formula, you can say that current is inversely proportional to 1 over R. Provided that V stays constant. So the V total again is staying constant, right? Changing the resistance doesn't change the V total, however it does change the I total. Okay, and that's how you would answer question 7. Okay, moving on to the last question, question 6. It said, firstly it was the multiple choice. It said the potential difference between 2 points is given as such. So we were told here is the potential difference V. A power source transfers so many 400,000 joules. So this is work. When moving a certain amount of charge, okay, so Q, which is unknown, between these 2 points. What is the amount of charge? Okay, so they want charge that has moved between these 2 points. So it's talking about charge, you have work and you have volts. So volts is equal to work over charge. And charge is equal to work divided by volts. And now the work they said was 400,000 joules and the volts was 17,400. So if you put that on your calculator, you will get 22.99 coulombs. So the answer is B. Okay, then question 6, it gives you 2 circuits. So it starts by saying that circuit 1 and 2 of 2 resistors, 4 and 8 ohms respectively, a bulb of resistance Rx, and an ammeter of negligible resistance connected to a 14-volt battery as shown. Okay, it says the reading on the ammeter in circuit 2 is 2A. Okay, firstly define the term current in words. Okay, so this is something that you would have to know. So current is the rate of flow of charge. Okay, simple, 2 marks. Calculate the potential difference across the parallel combination in circuit 2. So they want to know the voltage across this parallel part of the circuit. So if you calculate the voltage through this part, you have the voltage of the entire thing. So you can just say, well, V is equal to I times R. You can see that that would be 2 times 4, which is just 8 volts. Okay, 6.3.1, it says, now determine the resistance of bulb Rx. So the resistance of bulb Rx now, we can try and figure out. So let's start by thinking, okay, So we can calculate the voltage. Well, we don't have to calculate it because we know it. We know that the voltage through R1 is going to be 8 volts, which is the same as the voltage through R2. So I can figure out what the voltage is now of Rx, because if it's 8, then I can say, well, 14 minus 8 will just give me 6 volts. So the voltage through Rx here is 6 volts. So I'm going to write that. I'm going to say, well, I know that the voltage through Rx is equal to 14 minus 8, which is 6 volts. Now, in order for me to calculate the resistance, I need the current. So I'm going to say, well, if R is equal to V over I know it's 6 divided by the current. Now I don't know. The current is equal to the total current that would go through here. So the only way to find the total current is to figure out, if I know that there's 2 amps here, how many amps goes through here. Now I know, okay, but I have the voltage as 8 volts, 8 volts. So I can find the current. I can just say, well, the current through the 8 ohm resistor is equal to V over R, which is equal to 8 divided by 8, which is 1. It is 8, yes? Yeah. Amp. So that means that the current, the total current, is going to be equal to 1 plus 3. 1 plus 2, sorry, which is equal to 3. So that would be the total current. So we can use that here, and we can get 2 ohms. Okay, so alternatively, if you wanted to, you could have first found the current, the total current, and then worked out what the total resistance was. So if you found that the total current, so method 2, I'll just put here. Method 2, you would have done this part first, and you would have found the total current to be 3 amps. Then you would have said, well, R total is equal to V total over I total, which is 14 over 3, which would have given you 4.67. And then you could have said, well, you can calculate the resistance on the parallel part. So then you would have had to say R parallel is equal to 1 over 4 plus 1 over 8 to the negative 1, which is equal to 2.67. And then you could have minus that here, and you could have said, well, 4.67 minus 2.67 would have gotten you the remaining resistance, which would have also been 2 ohms. So either way, either method would have worked. Okay, so perhaps I should move this down so that it's just is a bit easier to read. Let me erase this, and then I'll move this up. Sorry, I'll continue now. I just want to make sure that the note is looking fine for you as well. I'm sure you can see method 2 because I've done it in a different color. Okay, so had you tried to do method 2, then you would have also had to have done this part as well. Okay, so you would have done this one first and that one second. But method 1, I think, was a bit easier. You would have just done the whole thing as you see it there. Okay, then 6.3.2 says, what is the charge passing through the bulb in 3 minutes in circuit 1? Okay, so you've already now found the resistance of R to the power Rx. Right, you found Rx to be equal to 2 ohms. So that can't change. If it's 2 ohms there, it's 2 ohms here. So in order for us to find the charge passing through, so Q delta T, I need I. So I would say, well, I is equal to Q over delta T. So Q is equal to I multiplied by delta T. The delta T is 3 minutes, which I know is going to be 180 seconds. But now in order to find the current, I need to figure out, okay, well, I can see that the total current would equal to V total over R total, which is the same as 14 divided by 2 plus 4 plus 8. 2 plus 4 plus 8, which is going to be equal to 1 amp. Okay, so let me move this down to my other calculations. So you would have put a 1 ampere and then you would have gotten a total of 180 coulombs. Okay, so that's how you would have answered that one. Okay, I'll move it down to the right one. So in order to find this, you would have had to first calculate the total current, because that's the current that goes through resistor Rx. Okay, so that's the answers to the exam questions. So now you can rule off. You'll write today's date, which is going to be the 8th, and the heading is ohmic versus non-ohmic resistors. Okay, so when it comes to resistors, okay, you have two types of resistors. You have ohmic and you have non-ohmic resistors. Now, when it comes to non-ohmic resistors, okay, we can't use any sort of calculation with non-ohmic resistors because they are non-ohmic, so they don't follow Ohm's law. So remember that from Ohm's law, right, we state that the ratio of voltage divided by current is constant. Which is supposed to be the resistance. Okay, the condition in order for this to be constant is that the temperature must be constant as well. Okay, so when a resistor, when the temperature is not constant, then we have a non-ohmic conductor. Okay, so basically, if we had to try and define the difference, the main differences is obviously the fact that the one obeys Ohm's law and the other one does not. So we have ohmic conductors versus a non-ohmic conductor. Non-ohmic conductor. So ohmic conductors is what we've already been discussing. So it obeys Ohm's law. So Ohm's law states that if the temperature is constant, then V is directly proportional to I. If temp is constant. Okay, if temperature is not constant, then it is a non-ohmic conductor. Okay, so if this is true, then the ratio V over I is equal to R, which is constant. Okay, now let's look at non-ohmic. Now, if it's a non-ohmic conductor, well, does not obey Ohm's law. So, what does that mean? It means that the temperature changes. So we can conclude and say, well, therefore, R is not constant. So the resistance doesn't stay the same. So important is that we must be able to look at this graphically. Okay, the graphs are coming. So let's think about what this relationship is saying. It's saying that if we have a directly proportional relationship, a direct relationship between V and I, if I had to draw a graph between the voltage versus the current, okay, I can see that what happens is that this ratio, V over I, now if you think about V over I, in this case it's the same as Y over X. So a change in Y over a change in X is equal to the gradient of the graph. So in this case the R is the gradient, the resistance. So it makes sense then that as I increase my current, remember they're directly proportional, so if I increase the current, I'm going to increase the V. So there is a directly proportional relationship, so there is a constant gradient change in Y over change in X, and a change in Y over change in X is equal to the resistance. Okay, but now if I have the same graph for non-ohmic conductors, where I'm looking at the current versus the voltage. Remember to pause the video if you need to draw or take down any notes, because I am going a bit fast. So what happens is that gradient is not going to be constant, so it's going to be exponential. So what happens is that the relationship is still true, that as the current increases, the voltage will increase, but it will increase exponentially instead of a constant gradient. So you can see that R is not constant because the gradient is not constant. So rather, an important point here to note is that it is the tangent to the curve that gives the resistance at a particular temperature. So that means that if you want to know what the resistance is, you would have to go to a particular point on the graph and you would have to find the tangent. So the tangent would be the straight line that would essentially touch that graph. So the gradient of this straight line would equal to the resistance at that particular point. But the moment that you go to the next point, the gradient has changed. And the moment you go to the next point, the gradient is different. So it's the tangent of the curve at that particular point. The gradient of that graph is equal to the resistance at that particular point. Okay, but we won't ever really ask you to calculate that because that requires knowledge of calculus, which we don't do at this level. Okay, so if you go to exercise 23 to question number 12, we'll answer that question together. Okay, so it says an experiment is conducted to verify Ohm's law. Okay, it gives you all the information on the circuit that you can read through, so pause if you need to read through the question. So it tells you that there's an EMF of 1.5 each cell. So again, there is going to be an EMF of 6 volts. So the first thing it says, write down Ohm's law in words. Okay, so you should be able to write this down. I'll write it for you, even though it's just directly out of the sags. So it's the current through a conductor is directly proportional to the potential difference across the conductor provided the temperature remains constant. You cannot write the shorthand for temperature, you must write the full temperature. Okay, then it says the switch is closed and the 6 resistors R1 to R6 with each with a different resistance are placed in the place of R. So they put 6 different resistors in the place of R, one at a time. The voltmeter and ammeter readings are then recorded. So they add different resistors, okay, everything else stays constant, and then they show you what the reading on V2 is and the reading on the ammeter. Okay, so just some things that you should notice when you're looking at the table. Notice that as the resistors are the different resistors are adding, you can see how the current is changing. So you can see as every resistor is added, the current is getting bigger. I mean the voltage, sorry, I'm reading the wrong thing. The voltage for the parallel part is getting larger. And you can see that the current is also getting larger. Okay, so it says use the graph paper provided and draw a graph of potential difference versus current using the table above. So we're going to draw potential difference versus current. So we'll draw a y-axis and our x-axis first. And you can see that you'll have your potential difference in volts. And your current in amps. Okay, so I suggest at this point you pause the video and you take time to plot this graph in your textbook, and then we'll go over the questions. Okay, so you can see that we're going to go from 0 volts until 4 volts, and we have from 0 amps all the way until it goes up in decimal increments. So let's have a look and see how much we can fit in. So you count, you'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if there is 15, then we can measure the voltage up in 0. Let's do, it goes 1.4. So if we do 0, then we can go up by, let me just see, 0.1 wouldn't work because we wouldn't be able to get all the way to the top. So we said 15, so let's say 4. Okay, we can go up by 0.3 if you want. Okay, that should also be fine, but I mean I wouldn't really recommend it. So let's see, if I go 0.2, 4, 0.681, right? Let's just double check that. Yeah. Okay, then I don't think we're going to make it to 4. Okay, so then let's do less than that. Okay, so we'll go 2, 4, 6, 8, 1. Let's see. 2, 4, 6, 8, 2, 2, 4, 6, 8, 3, 2, 4, 6. Oh, we just miss it. Okay, so then we'll go slightly less then. So let's do 0.3, 0.6, 0.9, 1.2, 2.1, 2.4, 2.7, 3.0, 3.3, 3.6, 3.9, 4.2. Okay, and then let's see the current. We can do, let's go 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2. Okay, let's see. So we would start at 1.2 and 0.5. There. We're going to use x's to plot. Okay, that's part of our goal here. So we'll do x there. Okay, by 0.5 and 1.2, and then we have 0.6, 1.4, 0.6. So we have 1.5, so we'll just go slightly lower than 1.5 to 0.6. Then we have 1.9 to 0.8, 1.9 to 0.8. Yeah, so I wouldn't actually have used this necessarily, but it's fine. It will should still work. 2.4 and 1, 2.4 and 1. Okay, and then 2.9 and 1.2, 1.2, 2.9. Okay, and then 3.6, 1.5, 3.6, 1.5. Okay, and then make sure if you did it correctly, you should have a straight line. Okay, it might not go through all the points, but it should go through at least most of them. Okay, and then we go to the origin, because obviously 0 would be 0 as well. Okay, so, and make sure you go past that last point as well to show the relationship, so we can see that there's a straight line. Okay, what does the gradient of the graph represent? Resistance. Okay, specifically not just resistance, but it represents the resistance of the parallel combination. How will the gradient of the graph change if voltmeter 2 is only connected across the 4 ohm resistor, right? Increases, decreases, or remains the same. So if the voltmeter was only on the 4 ohm resistor, it should be the same because it's recording the effective resistance parallel. So it would be the same. Okay, it doesn't change. Stays the same. If the 4 ohm resistor is removed, how will the gradient of the graph change? Right, only increase, decrease, or remain the same. So if I remove the 4 ohm resistor, what would I do to the total current, the total resistance? If I remove the 4 ohm resistor, would increase. So if the total resistance is increasing, then the gradient is going to increase. Calculate the resistance of R3 using the values in the table. Okay, so they want to know the R3. So you were told the voltmeter reading is 1.9 on V2. You were told that the ammeter reading was 0.8. Okay, they want to know what the resistance R is. So you know what the EMF is, it's 6 volts. So let's start by figuring out, okay, if it's up to you, I think the easiest way would be to calculate the voltmeter reading over the R, which would be this 1.9 minus the 6. So the voltmeter reading for R is 6 minus 1.9, which is 4.1 volts. And then we can calculate the resistance by saying, well, it would equal to V over I, which is equal to 4.1 over the total voltage, which was 0.8, which would have given you a total of 5.13 ohms. Okay, alternatively, you could have found the R total. You could have used the R total part. So you could have said, well, you know that if EMF is 6 volts and A is 0.8, you could have said, well, R total, let me do it in a different color. R total is equal to V total over I total, which is equal to 6 over 0.8, which is 7.5 ohms. Then the R of the parallel component is equal to 1 over 4 1 over 4 plus 1 over 6. We didn't calculate that already. No. 1 over 4 plus 1 over 6 to the negative 1. 4 plus 1 over 6 negative 1, which will give you 2.4 ohms. So then R would equal to 7.5 minus 2.4, which would give you the same one, 5.1. Okay, so both methods is perfectly acceptable. Okay, so another way, if you really wanted to also, is instead of calculating the R parallel like this, You could have also found R parallel, so let me do it in a in a different color. So just so you know, or R parallel could have also been found by using the voltage and the current. So you could have said is equal to the voltage over the current, which is 1.9 over 0.8, which would equal to 2.375 ohms. So you could have also found that like that, and then you would have said R is 7.5 minus 2.375, and you would still get R to be equal to 5.125 ohms, or 5.13. So either way, both methods are perfectly, well, all three methods would be perfectly acceptable. Okay, so that is where I'm going to end this particular lesson. So please make sure that for homework you go over whatever you needed to, but I want you to do number 13, number 14, and then that's it. So just those two questions for homework, and then that concludes Ohm's law. So our next lesson we're going to move on to the power calculations. Okay, so make sure that you go over the videos again if you need to. Make sure that you're practicing. If you want to start on the exam questions so long, then you can do that so that you're ready for when I get back. So you can ask me as many questions as you need, and just make sure that you are with it. Okay. Otherwise, then make sure that you're also prepared, because circuits is going to be your first practical task as well. Okay, so you must understand this and how we've done now ohms versus non-ohmic resistors, so that we can also see how we're going to test it in the practical as well as in the exam. Okay, but otherwise then good luck, and I'll see you on the next one.